I told you we'd be right back. 10.4 sound. What the dealio? Alright, so a sound wave is going to be caused by computer work, a vibrating source. These vibrations are always going to come out from the center of the source, and they're going to move outwards. And they do so in these kind of ringed cones. That's not a cone at all. That is a square. Undo. Circle. There we go. So picture it like that. They come out, and they come out right from the center. This causes a force vibration on your eardrum, so your eardrum begins to vibrate. And we interpret that as sound. How fun! This is kind of what it looks like. So if you can picture these black dots here as our particles, as our gases traveling through the air, and then we get our compressions and refractions in between, and that's our wave. How fun is that? So with everything else, the velocity of a wave is determined by the medium. In most cases, sound travels through the air, but it can also travel through other substances like helium. So you're not supposed to breathe in helium, but let's say hypothetically you did. I don't know, you're at a birthday party, you had a bunch of cake, you're all hopped up on fruit punch. I don't know what the case is. But let's say you take a balloon that's floating around and you suck in the helium, and your voice all of a sudden sounds like Alvin and the Chipmunks. If you don't know what Alvin and the Chipmunks sound like, just picture a voice that's really, really high-pitched like that. The reason is it's traveling faster, much faster, through that air, and therefore it relates as a higher frequency. Alright, so let's give that a try. So let's say we have a piano, and this piano is going to emit some frequencies, and they're going to range from a low of 28 degrees, so we'll call that frequency 28 hertz, to a high of 4200 hertz. And we need to find the longest and shortest wavelengths attained by this instrument. So that speed, again here, is 340 meters per second. Now remember, the temperature does affect the speed of sound. So typically it's like you add a degree for every degree above zero you get. You add 1 meter per second. And anyways, so back to this, not that directly pairs. So we're going to use our wavelength formula, and we are looking for wavelength at these two frequencies. So wavelength at 340 divided by 28, and wavelength number 2, which is 340 divided by 4200. And we should get two separate wavelengths. One that is 12.14 and one that is 0.081. Alright, the next thing we want to talk about when we deal with sound is this thing called volume. All of our headphones and iPods, can't use iPods anymore, iPhone, Android, whatever, you're on YouTube, Netflix, whatever, you got the TV remote in your hand, you want to turn up the volume. So the volume of a sound is determined by the amplitude of its vibrations, and we can measure it in two different ways. How intense that volume is, how much power or energy that sound is carrying over, or the decibels, which is just a ratio of the sound pressure. And here we have a chart that has intensity, decibels, and kind of an example of each one. So we can barely hear it here, and anything over, where is it at? There is a threshold pain, there it is. Anything over this is actually going to sound painful to our ears and could cause permanent ear damage. One of the most common is this thing called ring ear, where even after the sound has stopped, your ears continue to ring for an indefinite period of time, and that's caused by this intense pressure. Alright, so let's take a look at this. Suppose I turn my stereo up from 30 decibels to 70 decibels. How many times louder is that, or more intense? So I'm going from 30 to 70. Now keep in mind we're looking at intensity. So notice that intensity is going up by powers of 10. So it's not necessarily just going up 40, it's actually going up 10,000 times, right? 10 to the fourth power. So it's going up 4 times, which is 10,000 times more intense. Okay, next thing we want to talk about is a thing called pitch. So pitch is determined by frequency. So just like volume is determined by amplitude, pitch is going to be determined by frequency. And humans, again, have a set frequency of sounds that we can hear. So anything that is greater than these frequencies that we can hear is called ultrasonic. Anything that is underneath is called infrasonic. So if we can hear it, it's just sonic. Above it, ultrasonic. Below it, infrasonic. Unrelated, but yet still very similar, are things that we have a tendency to talk about, and that is when something goes faster than the speed of sound, and we call that supersonic. And then there's just subsonic, which is anything that is not going the speed of sound. Great. How fun was that? Anticlimactic, I know. Alright, so fundamental frequencies. This is the natural frequency. This is the frequency that if you were to have a guitar and you weren't to hold anything on the bridge and you were just to pluck one string, what frequency it would make. This is the natural fundamental frequency, also known as N equals 1. Fundamental. That's the first harmonic, first frequency. Resonance. This is going to happen when we cause a forced vibration by matching that natural frequency. And this is where harmonics come. Essentially what we're doing is we're increasing the amplitude. It's like if you're on a swing and you start pumping. You have to pump at the right spot, and as you do, your swing gets bigger and bigger and bigger. That's also how you can break glass using only the power of your voice. I have a really sweet video here of this kid breaking glass with his voice, but I'm not going to show you the whole thing because you can always look it up on YouTube. It's pretty funny though, so I'll play you a little quick segment here before I cut it out.
My name's Chase, and I
That's
live in
Chase.
California.
I don't know if this is too loud or not. I'm going to turn the volume down.
Try to break this wine glass by...
I don't know what kind of animal that is, but it freaks me out. Anyway, so let me fast forward through. He's warming up. He's warming up. See, he did it. I know. Spoiler alert. Right, here he goes. Ready, set. Oh my God! He broke glass. You don't want to do that at home. Don't do that at home. I broke glass.
This wine glass.
All right. Anyways, I will catch you next time with 10.5 notes. All right. Later.